to inequalities. Today we are going to focus on writing linear inequalities. And an inequality is a mathematical sentence that just compares expressions. Your inequalities can contain greater than, less than, greater than or equal to, or less than or equal to within the inequality. Some of these key phrases when you're dealing with less than is less than or is fewer than. For greater than is going to be is greater than or is more than. When you are less than or equal to, you can also use is at most or is no more than. And then with greater than or equal to, you can also use is at least or is no less than. So getting into our first part of these notes, we are writing each sentence as an inequality. So for example, A, we have a number W minus 3.5 is less than or equal to -2. So this is just going to be W minus 3.5 is less than or equal to -2. So when we have something that's equal to as well, that line goes underneath that inequality symbol. So it means that it includes that number as well. If there is no line underneath that inequality sign, or it is also not equal to, then it doesn't necessarily include that number. So when you are drawing these on a number line, you use different symbols for the two to represent if it includes that number and then if it doesn't include that number. For B, we have 3 is less than a number n plus 5. So when we write this, we can just do 3 is less than a number n plus 5. So 3 is less than n plus 5. For C, we have 0 is greater than or equal to twice a number x plus 1. So 0 is greater than or equal to twice a number x. We're going to use x, so 2x plus 1. For D, we have a number B is fewer than 30.4. So B is fewer than means is less than 30.4. For E, we're given -7/10 is at least twice a number k minus 4. So we can start with writing that -7/10 is at least means that -7/10 is greater than or equal to twice a number k minus 4. So it's 2k minus 4. When we sketch the graphs of linear inequalities, the solution of the inequality is the value that makes the inequality true. An inequality can have more than one solution, and the set of all solutions of an inequality is called the solution set. So for example, if you had something like x plus 5 is greater than or equal to -2, you would just solve this the same way that you would an equation and move the 5 over. So that way you get what x is greater than or equal to. You can also see with these examples that we're going to go into, it's asking if a specific value for that variable sets the inequality as a true statement. If it is, then it is a solution. If not, then it is not a solution. So if we look at example 2a, we're telling whether -4 is a solution of the inequality x plus 8 is less than -3. So the only thing we have to do is substitute in that -4 for x and simplify. So if we have -4 plus 8 is less than -3, Negative 4 plus 8 is the same thing as 8 minus 4, so that's just 4 is less than negative 3. This is not a true statement, so negative 4 is not a solution. For B, we have negative 4.5x is greater than negative 21. If we do this, we have a negative 4.5. We plug in that negative 4 for x is greater than negative 21. Well, we know that a negative times a negative is a positive. So either way, this positive number is going to be greater than negative 21. That's going to be true. So yes, negative 4 is a solution to this. If you did multiply it out, you would get 18 is greater than negative 21. So this is a true statement. So negative 4 is a solution. For the next set of examples, we are telling if negative 6 is a solution of the inequality. So for A, we're given C plus 4 is less than negative 1. So negative 6 plus 4 is less than negative 1. Negative 6 plus 4 is negative 2. And negative 2 is less than negative 1. So this is a true statement. The negative 6 is a solution. For B, we have 10 is less than or equal to 3 minus m. We're going to again plug in that negative 6 for m. This is going to give us 10 is less than or equal to 3 minus negative 6. The 3 minus negative 6 is going to turn into 3 plus 6. So 10 is less than or equal to 3 plus 6. The 3 plus 6 gives us 9. So we have 10 is less than or equal to 9. This is a false statement, so negative 6 is not a solution. For C and D, we're continuing to plug in negative 6 for that variable. So we have for C, 21 divided by x is greater than or equal to negative 3.5. So this is going to give us 21 divided by negative 6 is greater than or equal to negative 3.5. The 21 divided by negative 6 gives us negative 3.5. So that's negative 3.5 is greater than or equal to negative 3.5. This is, in fact, a true statement because negative 3.5 is equal to negative 3.5. So negative 6 is a solution. For D, we're given 4 times x minus 25 is greater than negative 2. So again, we're just plugging in that negative 6 to give us 4 times negative 6 minus 25 is greater than negative 2. We're going to do the 4 times the negative 6, which gives us negative 24. Minus 25 is greater than negative 2. The negative 24 minus 25 is the same thing as saying they're the same sign, so keep the sign and add the numbers. Going to give us a negative 49 is greater than negative 2. Negative 49 is not greater than negative 2, so this is a false statement, so negative 6 is not a solution. So just like I mentioned previously, when you are graphing these inequalities, it depends on your inequality sign on whether or not you're going to have a certain symbol on that number. So what I like to do with all of these is I like to make sure that when I'm looking at my inequality, my variable comes first. If that's the case, my variable comes first, my inequality sign will tell me which way to draw my line. So looking at that inequality sign, if we have something that's greater than or less than, so something that's not equal to that number, we're going to have an open circle on the number in the inequality, and then our line would run the same way that that inequality sign points to, as long as our variable comes first. If we have something that's less than or equal to or greater than or equal to, so it includes that number, we're going to have a closed circle on that number. And then again, we would use that inequality sign to tell us which way our line runs if our variable comes first in our inequality. So if we look at example A, we have y is less than or equal to negative 3. So we're going to have a negative 3. I'm going to put that here and just do negative 1, negative 5 around it. So my sign here, first off, my variable comes first, so I'm good to go. My sign points to the left, so my line's going to run to the left from that negative 3. Now, that inequality says equal to, so it's going to be a closed circle on negative 3. And then again, that line just runs to the left because the inequality sign runs or points to the left. Now, if you see here, it's very important the way that you draw these lines and where you put these circles. Your closed circle or your open circle either has to be on, or either way, it has to be on the number line. Your line can either be on the number line or above the number line, but it has to connect to that circle. Okay, so if you wanted to take this number line and pull it up here, that's fine as long as it connects to the circle. So it has to touch the circle. I like doing it on my number line as long as I'm working in Notability because I have different colors that I can use. But if I'm working on paper with a pencil, I like to either do a squiggly line to represent that line or to, like I said, pull it up top and just make sure that it connects with my circle. So I'm going to do the next one like with that squiggly line like I was telling you. So for B, we have 2 is less than X. My variable doesn't come first here, so I'm going to rewrite this to where my variable comes first, and it's just going to turn into X. Keep my sign open to the term that it's open to, so it stays open to the X, is greater than 2. I'm going to put my 2 down, and the numbers that surround it. Now here, my sign tells me that it's not equal to 2. So I'm going to have an open circle on that 2. And then from there, I'm going to use my inequality sign to point my line. It's pointing to the right, so my line's going to run to the right. So again, this is just another way to do it to where my line is a squiggly line, so I see the difference between my number line and the line I'm drawing over the number line.
Miss Glick,
Yes.
just for like test purposes, when it's greater than, is it the open circle or the closed circle? I'm still a little bit confused on that.
So if it's greater than or less than, it's an open circle. In order for it to be a closed circle, it has to be equal to the number as well. So your greater than or equal to, or your less than or equal to will be your closed circles. Does that help, Francesca?
I'm still a little bit confused. Can you explain it again?
Yeah, so when you have an open circle, it doesn't necessarily include that number. So that's why you only use your open circles when it's less than or greater than. When your inequality has that equal to in it, it includes that number. So a less than or equal to or a greater than or equal to includes that number, and that's when we'll use a closed circle. So if we don't have a line underneath the inequality sign, it's just an open circle. And then if there's a line underneath the inequality sign, it's a closed circle. Did that help, Francesca?
Yes, that helped. Thank you.
You're welcome. For C, we're given X is greater than 0. So this one does not have a line underneath the inequality sign. So it's going to be an open circle on 0. I'm just going to put the 0 here. I'm going to do 2 and -2 around it. So I'm going to have an open circle on that 0 on the number line. And then my line is going to go to the right since my inequality sign points to the right and my variable comes first. So I'm just going to draw my line to the right. Make sure I have the arrow on it. So again, I'm doing this in different ways for you to see the different options that you can write or draw these lines over your number line. For D, we have B is greater than -8. So again, this one is not equal to, so we're going to do an open circle on that -8. And then our line is going to run to the right since our variable comes first and our inequality sign points to the right. For E, we're given 1.4 is greater than G. So I'm just going to rewrite this to where G comes first. I'm going to keep that sign open to the 1.4 since it starts open to the 1.4. And then I'm going to say to myself, I'm going to have that 1.4. So I'm going to do this as 1. This is 1.5. This is 2. My circle is going to be open since I do not have a line underneath that inequality. And it's going to be really close to that 1.5, but not on it. And then my line's going to run to the left since my sign points to the left and my variable comes first. For F, we have R is less than 1/2. So again, I'm going to find that 1/2. I'm going to just do 1 and 2. So my 1/2 would be in between 1 and 2. I'm going to have an open circle on it since my sign does not have a line underneath it. And then my variable comes first. My sign points to the left. My line's going to run to the left. For G, we have V is greater than or equal to the square root of 36. The square root of 36 is 6. So this is the same thing as saying V is greater than or equal to 6. So on my number line, I'm going to find that 6. With this one, I'm going to have a closed circle since there is a line underneath that inequality. So it includes that 6. And then I'm going to say to myself, which way does that inequality point? To the right. So my line's going to go to the right from that closed circle on 6. In example 4, we see different graphs that are graphed for us, and we're coming up with the inequality that represents that graph. If we look here, it says the graphs show the height restrictions H in inches for 2 rides at an amusement park. Write an inequality that represents the height restriction of each ride. So for ride A, we're at 48. We're going to write down that 48. It includes the 48, so we're going to have a line underneath that inequality sign. That line runs to the right, so our sign's going to point to the right, and then we're just going to put our variable down. So we're going to have H is greater than or equal to 48. So for example, for the ride B, we know that we're dealing with height, so we can write H. The line points to the left, so my sign can point to the left. I have an open circle, so I'm going to just leave the sign the way that it is, no line, and then it's on 52, so just write the 52. So I did these 2 ways. You can do it the same way. So you can start backwards and work forward, or you can start to where you're dealing with your variable first and work back. Totally up to you. For C, we have a closed circle on that -6, and our line runs to the right. So this is saying that something is greater than or equal to -6. So if we're just working with H, we're going to have H. Our line points to the right, so our sign's going to point to the right. We have a closed circle, so we put a line underneath that inequality, and then our number is -6, so we just write down the -6.